Hello everyone, my experiment today is to make a lava lamp at home, and the main sort of learning focus of this is to explore density and its application in making lava lamps. A couple of disclaimers. This phone is sellotaped to a little cardboard box to try and hold it up, so sorry in advance if it falls over. I'm also not sure what the format exactly was for this lesson, and I'm aiming it towards my peers rather than students. So just to let you know, it is not appropriate for children. That doesn't sound good, but you know what I mean. Anyway, so to make a lava lamp like this, I need a glass. I'm going to need some oil, water, food colouring, and I've got Alka-Seltzer tablets, but really any fizzy tablets will do the job. So, in a little glass, I need to fill it maybe about a quarter full with water. Just a little bit of water in that in the bottom. And now, as soon as I start introducing oil, I can start talking about density, because the oil is less dense than the water. So, what do you think is going to happen? There we have it. It sits on the surface, and I'm going to fill about half the glass with oil. So half oil, quarter water. The main point is I need a nice thick layer of oil above the water. Next, we just need a little bit of food colouring. You don't have to mix it, but it's quite interesting watching the density here because it does some weird stuff with the water. Interesting to look at. Okay, and then lastly, you just need to add your tablet. So put this here so you can see it. I've broken the tablet up into little bits because it falls a little bit nicer, and then we'll just drop them in and watch it go. So as it fizzes, it's producing carbon dioxide, and carbon dioxide's bubbles will latch onto and carry up little droplets of water. And when they reach the surface, those drops of water lose their oxygen and they start to drop down again. And there you have it. We've got all our little bubbles going up and down. I'm actually getting a better view on this side. There you go. So really simple experiment that you can immediately talk about using. I think this is about to overflow. Put it away so you can't see it. Yeah, so this is a great experiment to talk about density. When I was teaching on my first placement, I was doing a topic on heat, and once we got into convection, I was warned by the teachers, quite rightly, that density is something the students really struggle with. So I think if I was explaining this, I'd take a long time going over density, using examples like a hot air balloon and how as a gas heats up and expands, it becomes less dense. That directly relates back to those lava lamps. The experiment's super simple. If you don't have these tablets, you can also use Beroccas. They're pretty good because, as well as being nice and fizzy, they turn the water orange. So you don't even need any food colouring either. This glass is a bit bigger. Also for the oil, I'm using olive oil. I tried vegetable oil as well, but it didn't work quite as well. I know it's slightly more fancy to use the olive oil, but you get less bubbles and stuff forming in the oil, so you get a nice clearer picture. But like I said, these tablets fizz up and dye the water for you, so you get some nice orange bubbles. The only downside of these tablets are there's a lot of less soluble stuff in Beroccas, so it does get a little bit cloudy, so it's harder to see what's going on, but you can still get that. Cool. Right. One other thing that's sort of a similar principle, lemonade and raisins, dancing raisins. I think we all saw this at the SUS thing in Glasgow. I found that you get the exact same principle. The raisins are more dense, so will sink to the bottom, but they promote the release of CO2 gas, so all those little bubbles of gas will latch onto the raisins and they'll float to the surface, lose that gas, and then sink back down again. I don't know why, but it works better in a sealed bottle, probably something to do with solubility of gases and different pressures and things. It just didn't dance quite as much when I did it in a glass. So if I shove a few raisins in and quickly put a lid on it, I get the dancing raisins. And they go up really fast when it's in a sealed bottle. Again, I don't know why, but when I did it in a glass, they just sort of went to the top and stopped and occasionally came down. But that's another really good way of showing the same principle. I focused on density with this when I was thinking about planning it, but it would also be really good for looking at buoyancy and displacement of air. That could even be a STEM project or something, designing ships, how much air needs to be displaced, because you can see when you've got enough air attached to the raisins, they'll float, but if you don't have enough air, they'll sink, type thing. Yeah, that's about it. Another thing I'd probably use if I was trying to teach this as a class is some really nice annotated pictures. This is something about how a microwave works, but I absolutely love these sort of scrapbook things.
Which makes them spiral outwards.
I don't need the sound. But a really nice
spin out like this.
Scrapbook where someone draws and annotates along with it. I'd need a setup and everything for this, which I don't have, and my stationery game is not strong enough either because I don't have any good coloured pens. But I'd use this sort of thing to draw some nice pretty diagrams as well. So that's it. Density, homemade lava lamp, dancing raisins.